Okay, I think this is where I got to before. So we need the calculator for this one. So we need to input the information. Now I've got a feeling I inputted it yesterday and then the calculator broke. Oh, what am I doing? So edit. No, it didn't, obviously. So we're going to input those numbers. So 1.25, 2.1.25, 2.25, 3.5, 4.4, 5.85. And then we need to put in the y values, 10, 13, 14. 17 and 19. Okay, so they're the values in the calculator. And then we need to find the regression line. So to do that, we press Stat, Calc, and it's here, linreg, so it's number 4. X list is list 1, Y list is list 2, so fine. And here we get our A and our B. So I'm just going to snip that rather than have to rewrite it. So there's our two values. Obviously we would round them to, oh, hang on, I think that's wrong. It is wrong, what's happened? Stat, edit. What happened there? .25. Oh, that should say 1.25. Oh, Miss Harrison. Okay, stat, calc, number 4. That's better. Right. Obviously, you're not going to know whether you've done right or wrong, but these are the right numbers. Okay, so we'd round those to 3 significant figures. So A would be 1.92 and B would be 7.98. Okay, so it's your values of A and B. Now, correlation coefficient. It should actually come up here, but if we go into our mode, you will see that our stat diagnostics is off. If you have a situation in the exam, you just need to go down to the stat diagnostic and turn it on. Quit. Go back to that same thing, so calc, linreg, and now it's actually giving us the correlation coefficient as well. Now we will try and remember to get you to do this before you go into the exam to check that your diagnostics is on, but if not, if you're in the exam, then just remember to do that. So R would be this value here, 0.985 to 3 sig fig. Use your equation, so you're now just going to use this equation here to estimate the mean weight. So let's quit that. So we're literally doing 1.92 multiplied by 1.95 plus 7.98. Okay, so we've used my equation here, and that gives us 11.724, so 11.7 to 3 sig fig. Okay, this is way easier than writing it. Okay, next one. So here we've got a graph. We know this value is 10. The easiest thing, because it's on the calc paper, is to actually sketch it on there. So let's type that in. So 2 ln x minus 3, close brackets. And I'm going to set my window. I don't need to go to the negative, so I can start at 0. I may want to go a little bit more than 10, So maybe 12. And I'm going to show each of my marks on my x-axis are worth 1. Okay, so I'm going to graph that. So it asks for, what's the first question? The equation of the vertical asymptote. So looking at this is value 1, value 2, value 3. Hopefully you can see that this graph kind of stops here, limitations of the graph here. So that would be our asymptote. So as an equation, it would be x equals 3. Okay, find the x-intercept. Again, you can see, hopefully, that that's a value of 4. If you weren't convinced, you could go to the second calc, see the calc here, and you'd be finding the 0 point. So 0. So it says left bound, so we have to move our cursor to the left. Enter. Then to the right. And we're saying left and right of the 0 area. Guess. And it's actually at 4. And we can also see it from the table here, so you shouldn't really have to have done that. So that's 4. The region enclosed is rotated around the x-axis. Find the volume of the solid form. So this is where we have to remember that this is volumes of revolution. It's going to be between 10 and 4 because it's where it crosses the x-axis and the other value, so that would be 10. And we've got 2 ln x minus 3 all squared, and that's multiplied by pi. So show that working. Obviously that's not very clear. So we can show that, and then it's on the calc paper, so we can chuck it in the calculator. So like that. So math 9. So this is 4. This is 10. This is, let's open up a bracket because we need to square it, 2 ln x minus 3. Oops, gone too far. Close the bracket, square it. Oops, dx. Okay, so this is just the. Oh no, that square's in the wrong place. So I need to close the bracket and square there. Okay. And this is the bit without the pi, so we have to deal with pi in a second. So that gives us 45, and then we multiply that by pi, which gives us 144. Oh, sorry, not 144 at all, it's 141. So there we go, that gives us an answer there. But as I say, it's on the calc paper, so 3 marks, you're not expected to do loads of work. If you're looking at this thinking you can't integrate it, you don't need to. Okay, you just literally chuck it in the calculator, but you show this working. Right, how do we have time? Alright, so we've got P intersect B dash. Right, so let's draw a little sketch. P and B. Oh gosh. So P and B. So P in. Oh, A. No. Oh. Right, there's A, B. So A intersect B dash. So A intersect B dash would be. Oh, B dash. Oh my gosh, it's this bit here. Okay, so A intersect B dash would be this section here. Now we know that PA is 0.62, so we know that this whole circle is 0.62, and we know that this intersection is 0.18, so therefore the shaded bit must be 0.62 subtract 0.18, which is 0.44. Okay. B. Given that PA union B complement is 0.19, find PA given that B dash has happened. Okie dokie. Okay, so I'd suggest we probably need to be looking at the formula booklet. What have we done there? I think it's called this one. Okay, here we go. So, okay. We're looking for probability. So here we go. So let's snip this bad boy. So we've got it where we want it. Oh, Alright, so we've got conditional probability thing happening here. So that's this here. So if we've got the probability of B given A, that would be the probability of A, B intersect A over the probability of A. So if they've got the probability of A intersect B dash, so the probability of A given that B dash has happened, we need to find the probability of A intersecting B dash. That's handy, we just found that. Over the probability of B dash. So we need to find the complement of B. So, so we know that A is 0.62. The intersection, so let's draw another little diagram here. So we know that this bit is 0.44. We know this bit is 0.18. Now they've given us A union B complement, so that means everything that's outside of A union B, so out here is 0.19. Well, that means that this part here is the only bit we're missing. So we're going to add 0.44 plus 0.1. What was it? 18 plus 0.19. 0.44 plus 0.18 plus 0.19 gives us 0.81. So that means this portion here is 0.19, which means that the probability of not B, oh, we didn't even need to know that, Thomas H, is these two added together. So the probability of B dash would be 0.44 plus 0.19. So that's 0.63. So the intersect of this is what we found up here. So that was 0.44. So we're looking at 0.44 over 0.63, which is 44 over 64. 63 just has it there. It's typical. And you don't have to simplify it. If you wanted to, you could write as a decimal, but there we go. Okay. Okay, so this is something about the velocity of a particle. And we need to find when the particle is at rest. Well, if the particle is at rest, then the velocity is 0. In other words, this function here is equal to 0. Now I have no idea what these numbers are, but it's the calc paper. So you've got a choice here. I would probably draw it on the graph. So we've got bracket 0.3 t plus 0.1 close brackets to the power t minus 4. Okay, that goes between 0 and 5, so you can change this to 5 and graph it. Okay, maybe we should change our Y scale because it looks nothing like that one. So let's just change our scale. So let's go from -5 to 6. I don't know why I chose those numbers, if I'm honest. Okay, doesn't really look like it still, but anyway, it's a bit better. Right, so we're trying to find this point here, so we are calculating the 0 value again, so 0. So it's left bound, let's put it a little bit closer to the point. Enter, and then right bound, just make it go past it. Guesses, and then it goes in. So that's our answer there. Oh, I missed it there. Oh Lord, what am I doing? Right, find the t value for when the acceleration is 0. So we need to differentiate this and find when that is equal to 0. Okay, sorry, got a call, don't know where I got to. So it says find the value of t when the acceleration of the particle is 0. So we remember, don't we, that the velocity and acceleration are connected. So the acceleration is the derivative of the velocity. So if the acceleration would be 0, it means that the derivative would be 0. In other words, it would be the minimum value of this function. Hopefully you understand all that. So because the acceleration has to be 0, that means that the derivative is equal to 0, and we know that derivatives, when they're 0, it indicates the maximum minimum values. So we can go back to our calc and do calc minimum point. Oh, what have I done there? Quit. Oops, oh my gosh. There's our graph. So calc minimum. So left bound. So we have to go somewhere on the left of the minimum point. Somewhere on the right. It's a bit flat, so I don't really know where it's going to be. Let's do this. Guess. And there we go. There's our minimum point. Okay, so obviously we've round these values to 3 sig fig. Okay. Here's our function. Maximum point A. Okay. Oh my gosh. So we need to know what do we want to know? The coordinates of A. So I would probably just draw this one as well. So y equals, let's ditch this. 12 cos x minus 5 sine x. Okay, we want trig graph 7. And we're in, so check our window. What's the point? So check our window. So we're going from, what's it, minus pi to 2 pi. Minus pi to 2 pi. And let's go every, we're used to going every pi over 2. Now, we know that goes from 12, 5. So we need bigger values here. So let's go -6 and 10. Let me change it again. Oops, too far. Let's go 15. And 10. Let's go -15. Alright, okay, we're good to go. Oh, they've told us the minimum value in Miss Harrison. Seriously. So f coordinates of A, so we're just trying to find this point here. So let's do calculate max. It's probably the best way of doing it. So we need to zoom all the way. Yeah, so left of that, enter. Right of that, enter. Guess, silly. And there we go. So that's our coordinate there. So we obviously round those to 3 sig fig. And write down the amplitude. So the amplitude. We can see that it's symmetrical back here. So if that maximum point was 13, plus we know the minimum is -13, so that means that the amplitude would be 13. The period is how long it takes to do one full cycle. So if it starts here and finishes here, I would suggest that the period is going to be 2 pi, because that's just before the 2 pi, that's just before the 0. If you didn't trust that, you could find this coordinate and then obviously find this measurement here, but I'm going to just go with 2 pi. Hence write it in the form P cos x plus r. So P tells us our amplitude, so that's 13. Oh, cos, and then x plus r, so x, and then the plus tells us our shift, our horizontal shift. So we could see that we went negative 0.395. That's the 3 sig fig. So this would be plus 0.395. Didn't need this bracket here. Done.